Alright guys, welcome to this page of the notes, and what we're doing is we're working our way through this idea of performing operations on functions, which I already said is just like performing operations on polynomials we did in the previous chapter, except instead of calling them polynomials, now we're just calling them functions, but it works the exact same way. So in the previous video, we looked at adding and subtracting functions, and really all you have to remember is that the trick is that if you're subtracting functions, you just need to remember to distribute the minus sign through the last function and then combine like terms. What we're now going to do is take a look at multiplying and dividing functions, which was just like multiplying and dividing polynomials. When multiplying, we're going to need to multiply it out using the distributive property, right? So we use the distributive property to multiply all the terms together, combine like terms, and then for the division, you'll either need to do algebraic long division, which we learned in the previous chapter, or if it's one of the situations where it applies, you can do synthetic division to save you some time and make it a little faster. So let's jump right into these and see how they go. First, I give you f of x and g of x. And then I give you this kind of weird notation. Again, you should be comfortable with it. I showed it to you on the first page of the notes. But if you didn't really like that for this first time here, I'll just rewrite it for you. Remember, this means the exact same thing as doing f of x times g of x. Right? So you're going to take f of x, the function f of x. You're going to multiply it by g of x. Well, that's not so bad. We can do that. That means that I'm going to do x squared plus 7x plus 12. I'm going to multiply that by 3x minus 4. Now, please feel free to draw your arrows if you need to so that you don't forget anybody, but it's just the distributive property. We're just going to start working our way through this. We need to make sure that we multiply everybody together. So here we go. X squared times 3x. Well, that's going to be a 3x cubed. X squared times a negative 4 minus 4x squared. All right, so now we multiplied the x squared by both of these guys. Now we go to the 7x. We'll multiply it by both of these guys. So 7x times 3x is going to be plus 21x squared. And then 7x times a negative 4 is going to be minus 28x. 12 times 3x is going to be plus 36x. And 12 times a negative 4 is going to be minus 48. All right, all we got to do is combine like terms, cross them off as you use them. 3x cubed is the only guy I've got that's cubed. My squareds. Let's see what I've got. I have a minus 4x squared and a plus 21x squared, so that should leave me with positive 17x squared. Cross those guys off. And then I have a negative 28x and a positive 36x, which should leave me with plus 8x. Cross those guys off. And then the negative 48 is the only guy I have that's a constant. And there you go. You just multiplied those two those two functions together, just like multiplying polynomials, except now we're just calling them functions. All right, down here, division. Well, they want me to do f divided by g of x, which again, remember, you can simply rewrite it if you want to as f of x divided by g of x. So f of x divided by g of x, which means what I have is x squared plus 7x plus 12 divided by 3x, not plus, 3x minus 4. Well, like I said, we've seen this before when we did division of polynomials back in chapter 5. The only difference here is now we're just calling it f of x divided by g of x. We're just calling them functions. It's the same thing though. In this case, remember, synthetic division is not going to work for this reason. First, the leading coefficient needs to be a 1, and it's not. I have a 3, and the power needs to be a 1, and it is. So the problem I've got is that that leading coefficient is not a 1. Synthetic division is out. We're going to have to do algebraic long division. No problem. Check to make sure you don't need any placeholders. 2, 1, 0. Again, I'm looking at the power on the variable just to check and see if I need any placeholders, but I don't. Everybody is there, so we'll go ahead and do our algebraic long division. The x squared plus 7x plus 12 is my dividend. It goes inside the long division symbol. The 3x minus 4 is my divisor. It goes outside. And remember, we run through that 4-step process. It is divide, multiply, subtract the product, bring down. Once you've gone through those 4 steps, you then repeat that process until you run out of things to bring down. And if you wind up with a remainder, we just write that remainder over our original divisor. I'll show you. So remember, we do a little bit of side work. I always start with the leading term of the dividend divided by the leading term of the divisor, which for us is going to be an x squared divided by 3x. Well, no big deal. X squared divided by x leaves me with an x. 1 divided by 3 is 1/3. So I have 1/3 x is the result of my division. That's step 1. 1/3 x. Remember, I'm going to line up all of the variables with the same exponent, right? So this is an x to the first, so make sure it goes over the rest of the x to the first. That way I keep my columns all nice and neat. It'll just help keep you from getting lost when doing the algebraic long division. So step 1 was divide, which I did. Now step 2, multiply. 1/3 x times 3x. Well, the 3's are going to cancel each other out. X times x is x squared. Okay, 1/3 x times a -4 is going to be minus 4/3 x. Right. That's multiply. Step number 3, subtract. Don't forget to use parentheses so that you remember to distribute the minus sign. The first 2 terms are always going to cancel each other out. X squared minus x squared is 0. They had better cancel each other out. If they don't, you made a mistake. Go back and figure out what you did wrong. And then we're going to go ahead and do 7x minus a minus, which means plus. So 7x plus 4/3 x. And we should wind up here with, let's see, what do we get? We get 25/3 x. Bring down the 12. Okay, so now I'm going to do 25/3 x. This is my reduced polynomial, right? The first term of that, 25/3 x divided by 3x. Okay, the x's are going to cancel each other out. 25/3 divided by 3. You can certainly do it on your calculator if you want to, but hopefully you recognize this is just a mixed fraction. You have a fraction in the numerator of an overall fraction, which means that denominator just gets dropped down, right? So it'd be 25 over 3 times 3, which is 9. So 25/9. All right, that's step 1, divide. Step number 2, multiply. 25/9 times 3x. Well, the 9 and the 3 reduce to a 3, so I wind up with 25/3 x. I'm then going to do 25/9 times a -4. 25/9 times a -4 is going to be -100/9. I know we're getting some ugly fractions, but that's okay. After distributing the minus sign, they drop out, which they should. If they don't, you know you made a mistake. And then we're going to do 12 negative, which means 12 plus 100/9. And so we are going to wind up with a remainder here. I wind up with a remainder of, what do we get? 208/9. As my remainder. So here we go. I'm going to write my answer. The result, right, of dividing f of x by g of x is the quotient plus the remainder. All right, so here we go. My quotient is 1/3 x plus 25/9 plus 208/9. Sorry, that's a weird 8. 208/9, all over 3x minus 4. Sorry, let me fix my 8. You guys should remember from the previous chapter that the way that this works, right, is we write our remainder over our original divisor. Okay, but this isn't, this answer is not going to be our final answer. There's a couple of things I need to do to it. First of all, our quotient needs to be in standard form, so I need the x's, the variables, to be in descending order of power, which they are, but my leading coefficients, my coefficients need to be integers, which I don't have, right? I've got fractions. I've got 1/3 and 25/9. So what we're going to do is we're going to multiply this entire thing by the LCM of those denominators, the LCM of 3 and 9, which of course the least common multiple of 3 and 9 is 9. So we're going to multiply this entire guy by 9 to get rid of those fractions and turn my coefficients into integers, which they need to be so that my answer is in standard form. Okay, well, here we go. 9 divided by 3, of course, is 3, so this becomes a 3x. 25/9 times 9, the 9's cancel, I'm left with 25, so plus 25. The same thing happens here. 208/9 times 9, the 9's cancel, and you're left with 208 plus 208, all divided by 3x minus 4. There you go. You've got your quotient written in standard form. It's in descending order of powers, and my coefficients are whole numbers. We can't get rid of that divisor. Remember, that's just how we write our remainder, the remainder over our original divisor, and that's your result of doing algebraic long division. Guys, head on over to the next page of the notes, and we'll try a couple more of these multiplying functions, and I'll meet you over there.